You want to show something is purely imaginary, you need to make sure it has no real parts. Okay, it has no real parts. Yeah. So we don't know what Z1, Z2 is. We just know they have the same magnitude. Okay. So I'm just going to let Z1 equals to R1 cis theta, and Z2 equals to R2 cis phi. Okay. And then plug Z1, Z2 into the expression we're trying to prove. So Z1 plus Z2 over Z1 minus Z2 will just be, so this is R1 cis theta plus R2 cis phi, and then Z1 minus Z2 would be R1 cis theta minus R2 cis phi. Yeah. And R1 equals to R2, okay, so we can see all the R would be cancelled because R1 equals to R2. Okay, they will all get cancelled. So Z1 plus Z2 divided by Z1 minus Z2, you're just left with cis theta plus cis phi divided by cis theta minus cis phi. Okay. And then we just need to use the cos and sine additions. Okay, so cis theta plus cis phi divided by cis theta minus cis phi. There's two different ways we can do it. Okay, let's just go through two different methods. Method one. Yeah, method one, I just want to divide everything by cis theta. Okay, divide everything by cis theta. Okay, divide everything by cis theta. So we just get 1 plus cis phi minus theta. Okay, because cis phi divided by cis theta is just cis phi minus theta. Divide by 1 minus cis phi minus theta. Okay. Yeah. And then because theta minus phi will just be another angle, so I'm just going to let alpha equals to phi minus theta. Okay. So this just become 1 plus cis alpha divided by 1 minus cis alpha. Okay. And then 1 plus cis alpha. Cis alpha is cos alpha plus I sine alpha. Okay. And I want to use my double angle formula. I'll leave that one for a second. Okay. Yeah, so I'm just going to use my double angle formula. So sine alpha, there's only one way you can do it. It just becomes 2 sine alpha over 2 cos alpha over 2. Okay. And then this cos alpha, there's many ways to do it, but we have 1 plus at the front. Okay, we have 1 plus at the front. So if we have cos alpha equals to cos alpha over 2 squared minus sine alpha over 2 squared, or 2 cos alpha over 2 squared minus 1, or 1 minus 2 sine alpha over 2 squared. Yeah, so you have 1 plus at the front. You want to cancel out the 1. You want to choose this formula here. Okay, so in that case, 1 and 1 will get cancelled. And similarly, if you have 1 minus cos alpha, then minus I sine alpha. Yeah. So for sine alpha, you still don't have a choice. It is 2 sine alpha over 2 cos alpha over 2. However, for this 1 minus cos alpha, to get rid of this 1, you need to have a positive 1. So for that one, we're going to choose this one over here. Yeah, so 1 and 1 will get cancelled. Okay, 1 and 1 will get cancelled. Yeah, so after we simplified, we'll have, yeah, and also all the 2's get cancelled out. Yeah, because every single term has a 2, so 2 all get cancelled out. I'll just skip one step. So we have cos squared alpha over 2 plus I sine alpha over 2 cos alpha over 2, and then sine squared alpha over 2 minus I sine alpha over 2 cos alpha over 2. Yeah, and then on the top part, okay, on the top part you can easily take a cos alpha over 2 out, so that is cos alpha over 2 cis alpha over 2. Okay. And down the bottom you can take a sine alpha over 2 out, and then we're left with sine alpha over 2 minus I cos alpha over 2. Yeah, but this is in the completely wrong order, right? Because cis is cos I sine. Yeah, so what we're going to do is we just take the minus I out. Yeah. So we have, yeah, so we'll just purely just look at the denominator, okay? We just want to take the minus I out. So once we take the minus I out, it becomes minus I sine alpha over 2. Yeah. And then minus I multiplied by, so when you take minus I out, this just becomes a pure cos alpha over 2. Yeah. And then minus, yeah, so minus I multiplied by positive I equals to 1. So this one would be plus I sine alpha over 2. You can double check the coefficient, okay? So sine alpha over 2 before, the coefficient is positive 1. And then you have a minus I multiplied by a positive I, overall it still equals to 1, okay? Everything is the same. And this part is also cis alpha over 2. Yeah, so cis alpha over 2, cis alpha over 2 cancelled. Cos divided by sine equals to cot, right? And then 1 divided by minus I equals to positive I. Okay? So I'll just quickly write it down here. So cos alpha over 2 divided by minus I sine alpha over 2 equals to I cot alpha over 2. Yeah. Yeah. So I cot alpha over 2. And you can see it doesn't have any real part, so this is pure imaginary. Okay, it is pure imaginary. Yeah, so this is just one way to do it, okay? If you don't remember any addition formulas and then you just remember your double angle formula, you can convert everything into double angle formula and then do it properly. However, if you remember the trig addition formulas, you can just expand this cis theta plus phi and over cis theta minus phi. Okay, let's just do it using method 2. Yeah, so method 2 will start with the same expression where you're left with cis theta plus cis phi divided by cis theta minus cis phi. Yeah. So cis theta plus cis phi, it would be cos theta plus cos phi plus I sine theta plus sine phi. Yeah, this is your top part, and then the bottom part will just be cos theta minus cos phi plus I cos theta minus sine theta minus sine phi. Okay, and then you just need to use the sum and product formula from trigonometry. Okay, yeah, so cos theta plus phi. Cos theta plus phi, it is 2 cos theta plus phi divided by 2, and cos theta minus phi divided by 2, and plus I. Yeah. So sine theta plus phi, it's 2 sine theta plus phi divided by 2 cos theta minus phi divided by 2. So this is sine theta plus phi. And then let's have a look at the cos theta minus phi. So for cos theta minus phi, it is minus 2 sine theta plus phi divided by 2 sine theta minus phi divided by 2 plus I sine theta minus sine phi. It's 2 cos theta plus phi divided by 2, and sine theta minus phi divided by 2. Okay. If you remember all those sum to product formulas. Okay. So you can see every single term has a 2. You can just cancel out the 2's, and then we can't really do anything at this stage. Okay. And then let's just try to convert the rest of the terms together first. Yeah. So all the 2's get cancelled, and then on the numerator, okay, on the numerator we have cos I. Sorry, I just circled the wrong part. So we have cos I sine. Okay, so that's the cis part, and then cos become the modulus. So at the front we have cos theta minus phi divided by 2, and then cis theta plus phi all over 2. Okay, so that's the numerator. So cis theta plus cis phi is cos theta minus phi over 2, cis theta plus phi over 2. Or we have cis theta minus cis phi. Okay. And then again, you just need to see the common part. So we have so just wait a second. I think I might copy down something wrong. Cos minus cos is sine multiplied by sine. Sine multiplied by sine minus phi would be cos sine. Yeah, I think everything is right. And yeah, we'll just quickly take out the common thing out first. So this is sine theta minus phi and sine theta minus phi. Those two looks exactly the same. We can take those two out first. So sine theta minus phi all divided by 2. And then we have cis. Sorry, it's not cis anymore. It just I cos minus sine. Yeah, if I just copy down everything properly. Yeah, so you have I cos and minus sine theta plus phi over 2. Yeah, again, we just want to convert this one into a cis formula. Okay, want to convert this into a cis formula. So what we can do is we want cis, which is cos plus I sine. Okay, we want cos plus I sine. So sine here is minus 1. Okay, sine here is minus 1. So if you want to convert this into I, you just need to multiply it with so you just need to multiply this with a minus I. Yeah, you just need to multiply everything by a minus I. Okay. So we have so we just multiply everything inside by a minus I, and then everything outside by 1 over minus I. Okay, so minus I multiplied by I become 1, minus I multiplied by minus 1 become I. Okay, so now we finally convert this into cis form. And then 1 over minus I, overall just a minus I, right? So we have minus I cos theta divided by phi over 2. Oh, sorry, yeah. So cos and sine, they are the same thing. So cos divided by sine will just be cot. Okay? Yeah, so we can just write this as cot theta minus phi all over 2. Yeah, and this also becomes cis theta plus phi over 2. Okay, so two of the cis part are exactly the same. So this is also cis theta plus phi all divided by 2. Yeah, so 2 of the cis part exactly the same. They just cancel, just become 1. Okay, so overall you can see it's minus cot theta minus phi all over 2 multiplied by minus I. Again, it have no real part, so it is pure imaginary. Okay, it is also pure imaginary number.